Good morning, everyone. Welcome to this session Reverse Engineering using LLM. I'm Vutukuri Sreenivas. I'm doing as a DevRel at Stackup. In the next 30 minutes, we are gonna discuss how the most complex problems modernizing the legacy systems using LLMs. Before I will get into the agenda, I would like to ask how many of you are here super comfortable with and understanding the COBOL language and programming in COBOL? I see one, two, yeah, only two hands rise up. Yeah, that's fine. That's what we are gonna discuss. So here's our agenda for this session. First, we are gonna talk why legacy is still there and why modernization can't wait. And then we are gonna see how LLMs can help us to go from our legacy system to the most modernization code into the Python and Java. And we'll see what are the tools and workflows that can help us and do the conversion of legacy system into the modernization work and the benefits, and followed by the case studies, the companies which are actually using the artificial intelligence and LLMs to convert the legacy into the modernization. And no system is 100% perfect, hence we will be having the risks and liabilities. We are going to see what are the risks and liabilities and how we are going to mitigate those, and we are gonna see how is 2025 in terms of AI and the future of the AI. So first, let's get started with some sobering statistics. There are around and over 800 billion lines of COBOL code still in the daily usage. We are, without knowingly or unknowingly, using the legacy code. 90% of the ATM transaction that we are doing actually now is rely on the COBOL system. That is the money we transfer, the balance we query, the money we withdraw from the ATMs are still running on this legacy code that is COBOL. So what's the cache here? So the cache is there are only few hundred thousands of developers in the worldwide available. So as we see here, there is only few developers who can understand the COBOL program and write the programming in COBOL. So think of the ratio. There is around 800 plus billions of COBOL lines, and it is maintained by only a few hundred thousands of developers. And those developers are approaching their retirement age very soon. So who are going to handle this? So, a recent survey done by the HFC Research states that there is around 1.5 trillion to 2 trillion global debt. It is not only about the maintenance of legacy systems. Because of unpatched security issues and flawless in old systems, these are vulnerable to modern threats. And this debt is it is total cumulated by the delay of legacy system into the modernization system, and the legacy systems aren't very easy to migrate into the cloud infrastructure. So hence the organizations are still has to depend on the most expensive on-premise data centers, and meanwhile the agility is also very important. Here I have included the link to the research paper. If you are interested, you can get into the research paper as well. So here are the well documented challenges of migration using the traditional systems. So first, the very psychic process is manual rewrites. The manual rewrites, which are pretty slow, it takes even years and decades for the very larger system. And human developers are trying to understand the very old logic which was built years ago or decades ago. And as we know, hiring the human expert really costs a lot. And the second psychic process would be a line by line translation. A line by line translations works pretty well in the technical use case, but it is actually unreadable and unmaintainable. The code looks kinda good, okay, it works technically fine, but in terms of maintaining that code is very hectic process. And for the legacy system which were developed decades ago, there were a number of patches were made, but that wasn't documented well. So we'll see why the LLMs could be the solution for this problem. As we know, the LLMs are not only trained in the natural human language, it is also trained in the millions of thousands of repositories, code repositories. The LLMs understands the semantic and grammatical context between each and every line. So it is much faster than the human expert who understands the code. So generally, if a human takes around 2 to 3 months to convert a small module of a legacy into the modernization, where LLM is taking within a few minutes, it is converting the legacy code into the modernization with all idioms and with preserving all idioms and semantic logic. So let us understand how LLMs can understand the legacy code in such a deep level. So it involves in the several sophisticated process. First being the tokenization. First being the tokenization. The LLM, the LLM models that we are going to train first breaks the COBOL legacy code into the small chunks. Uh, though, because the LLM cannot understand the large code at once, even if you try to uh, prompt the all large code at once, it may tend to give the answer but might be not 100% accurate. So we do the tokenization. What does the tokenization mean? We'll break the large code into the small chunks having the defined meaning, and these small chunks will be having the contextual embedding. We'll see these the COBOL is business oriented language. How these gonna translate it into the object oriented language into the modernization system. So for that, the contextual embeddings are pretty important. They preserve the context between each chunk. Then coming to the fine tuning, the we are gonna use CodeLlama for fine tuning our models, which will be having the patterns, because the CodeLlama is trained on thousands of different language repositories. Hence, it will provide the actual pattern how the final output gonna look. So let's get into the practical. How are we gonna do this? So our process is not gonna replace the human intelligence with AI. Our process is going to be uh, teach the AI with the human abilities, how human thinks, kind of how human thinks. If you think in a mathematical language, the complex numbers are defined as a plus ib, where ib is being the imaginary part. The main difference between us and the AI is lack of imagination and emotions. What if AI have the imagination power? Will it replace the human power? So our approach kinda be hybrid. We are not gonna replace human expertise with the AI. We are going to augmenting the human capabilities with AI and build a tool accordingly. So here's the architecture. Let me break down for you. The first step should be the extracting the legacy input. The legacy here we are using the anteller and anteller or open cobol for passing the legacy code which is not gonna directly input the data into the LLM models, but it will give the reason why this is being inputting into the model. Then, as I have said before, The LLMs kind of hallucinate understanding the large chunks of the data. Hence, we are gonna break that code and letting that into the semantic chunks. And the next step would be the translating it via LLM. This is where all the magic happens. The LLM's gonna not only give a prompt to just convert this COBOL code into the modernization code, but what it is actually doing is it provides all the one prompt, few prompt examples and the high quality translation code just to check if everything that is gonna change back is working perfectly all right with it. Then the next step would be the context preservation. I In a while I'll be showing one module that I have converted from COBOL to modernization language, how context is being preserved in the COBOL. The global variables and the variable context is preserved is is preserved, and who is going to manage, who is going to take care, how it is going to be, and what variable it might be in the modernization language. Let us say there is a picture class in the COBOL language. How it can be transferred into the modernization language, whether it is to be stored in the int data type, double data type, or a float data type. We will see that in a while. Next might be the post processing. The above input we get is a very raw input, but that needs to be refinement. Here we what we are gonna do is we'll do the fine linting, formatting, and dark strings to make the raw input into the more understandable. And then next step would be the output generated. The output generated here and the translated code will be finally reviewed by the human expert, because we are not removing the human expert in between. The human here will validate and check if the business logic is being maintained or not. If it is not maintained, then it's gonna cause a lot of chaos. Then after all conversion, we are not leaving this as it is. We are integrating it with CI/CD, which automates all this process. So here is a detailed architecture of how this is technically possible. So as I said earlier, here is a small module of the code. If you can see in the line 1 2 3 4, in the fifth line, if you see the picture class of 9 of 5 v99, which means 5 decimals before the implied decimal point, and do 2 decimal points after the implied decimal points, which is converted into the double. If you can see it on the screen, how is the LLM gonna know it is double? So this is a small example. And to be honest, no machine is 100% perfect. Hence, LLMs are hallucinate. LLMs do hallucinate. So how we are gonna solve this hallucination problem? For this, we can introduce a solution called in between the human loop and the CodeLlama translation. We can integrate a one new workflow which is called the LLM as a judge, where before prompting the translated code to the human expert, in between we can have the LLM as a judge, where the LLM itself judge whether the translated code, how much accuracy is being maintained. If not, it will retrace the all back and it will be um, get into the workflow again until it gets accuracy, that is till the LLM judge give clearance, then it will be moved to the human review loop. So this is the workflow. This is not just only the theoretical workflow, this is already being used by the very large banks in the world. In a while, let me show you um, some case studies which are using this workflow. The first one would be the JP Morgan. The JP Morgan there is one of the world's largest bank which is using the same approach to convert the legacy code into the most modernization code using Java. And if you can see it on the screen, um, the results were very impeccable. It is 60% faster compared to the manual traditional method, and 40% cheaper. And it is not only about the speed and cost, it is also about the scaling and securing the system. The LLMs know the and they are mostly updated with all security patches and everything from the legacy to till now. Henceforth, no need to worry about the security system. And the next case study would be the Japanese banks. Japanese bank. This is also one of the world's largest bank. It has converted 5 billion lines of COBOL code just in the 9 months. Just in the 9 months, as I have said earlier, yeah, these Japanese bank exactly use the same workflow that I have displayed you earlier. They have used the AI pipeline with a human review for the validation, and the result is pretty simple. They have maintained 100% functional parity, which means it is working as exactly as how the old legacy systems are working then and how the modernization system working now. And here is a link to the research paper as well. If you want to visit, you can visit. Then these are the benefits from the LLMs versus traditional methods. The speed is maintained, accuracy, cost, and scalability. The Yeah, and here are some of the benefits. Migration could be faster, cost reduction in the project, free space from COBOL experts who are shrinking actually, and no one are really interested in learning the COBOL language. I don't know why. Yeah, then it also preserves the business language and semantic understanding between the legacy code and the modernization code. And that being said, no technology is 100% powerful. It comes with some risks. So here are some of the risks that might be cause some chaos. So first one being the IP exposure. While we are prompting the data to the models, it may can leak our proprietary logic, and like we discussed earlier, hallucination in the codes, unauthorized reuses. What if LLMs are trained with our business logic? What happens if some others gonna copy everything? We humans are really interested in copying. Next, being the privacy being at risk. So how can we mitigate? Again, same the human in the validation part. Then having a better governance principles and rules to let our work done with the LLMs, not let LLMs do our work. Then finally, being the validation and automated tests. So, how is AI today as of 2025? We are having domain-specific models fine-tuned for every specific domains. We have IDE integrations, kind of like GitHub Copilot, and multi-models. We can now have the video model, document model, which handles codes, docs, and images. And where is the future going? What can we expect in the future from AI? Our personal computers and mobile phones are gonna talk back to us in a way that we can't even imagine. From basic holiday plans that we are experiencing now to the most complex defense analytics is the future. This artificial intelligence integrated with the human intelligence is the future, and we have to see where it tends to the. So, yeah, questions if you have any. Yes, please.
Two questions, please. One is, you said you use CodeLlama. So why CodeLlama? Why not IBM rewrite those models? Because IBM Watson, the feedback is that IBM Watson does a good job. Follow-up question is, you said a human should validate the logic. So that human should be a COBOL developer, or should be a Java developer, or should be a team of COBOL or Java developers?
Yeah. So here are the two questions. The first question is why CodeLlama, why not others? So the reason being the CodeLlama is open source and it is trained on the vast amount of data. And yes, we can use the IBM Watson as well. It is not being a very problem. And the second question, could you please repeat it again?
Yeah, second question is,
Oh yeah, yeah, I get it. I get. In the human as a review, is that human to be a COBOL developer or a Java developer? That is a question, right? So for that, the answer pretty much should be the human who understands both COBOL and Java. So yeah, okay, I'll say. Though in the first case, in the legacy system, um, to manually convert, we need a lot of developers. Let us say if we need a n developers who knows who are the COBOL developers. In this scenario, we'll be needing only n divided by maybe 50 or 100 developers. There we can reduce the number of experts. So it would be better if the person knows both the languages. If not, then the person should be a modernization language expert.
thank you.
Thank you. Yes, please.
Shouldn't you first then spend a lot of time on the testing framework, on the original code, and then see if the new code uses the same test results?
Mm-hmm.
Um, isn't that key? Because if you let the Java developer judge the Java code,
Mm-hmm.
I mean, he can still not see the business function that the code needs to perform. So is that safe enough to have the Java developer look at if the code performs the same function, or you should just invest more in testing the original code and run the same test?
Yeah. So here's the question. You are saying, do we need to invest much in the testing, or do we need to have a developer who understand the both the test cases, right? So the first thing would be the test cases might be different from the legacy code to the modernization code. It would be better if we include the test cases. We'll invest in the test cases in the earlier phase to to know not to have the much chaos in the later state when the code is modernized. And however, we are not going to remove the Java developer as well who understand the codes and test it accordingly. Yes, please.
Yeah, thank you for a very nice presentation.
Thank you.
I was wondering, do you see any blockers on like trying for a different in a different language, for example, Fortran?
Most probably not. The workflow might be the same. Yeah. Yes, please.
Thank you for your talk.
Thank you.
Smart people from IBM developed 20 years ago already systems to translate COBOL to Java.
Mm-hmm.
What are the key advantages of using this LLM approach?
Yeah, you are saying IBM is developed 20 years ago, but why is COBOL code is still in the existing phase? Why it isn't modernized yet? So that might answer your question. The LLMs are much faster compared to that.
Thank you.
Thank you. Any more questions?
By the way, how was the like the reception so far? I mean, from developers. I mean, have you gotten comments on people that are willing to use these tools to convert the kind of legacy code to Python? Or
Yes. The
curious about the reception from
yeah. So yeah, your question is: are companies are really interested in converting the legacy into the modernization?
because I mean I don't know, some companies were not willing to convert to maybe Python due to, I guess, I don't know, maybe hardware related or
Mm-hmm.
security related issues. I mean, I'm curious about how the feedback has been so far.
Yeah, so for the feedback was been so pretty well, and it is not only limited to the Java. It is modernization language. You can convert into any language that you want to. It is not only limited to Java or Python. If you want, you can convert into Go as well. um so for the companies are still in the kiosk whether to modernize or not, and yes, the feedback was pretty fine. Thank you. So questions?
So, when you are told that you had broken down the project into semantic chunks,
Mm-hmm.
what kind of chunks were they? Like,
So let me tell you in let me take a English sentence example and break it down. Let us say, may I know your name, please? Manorit. So let me take an example. Manorit likes biryani, which is a Indian cuisine. Fine, right? Yeah. Manorit likes biryani, which is Indian cuisine. So here, now what chunking means, the every word is being divided into pieces. Manorit likes.
so is it like tokenized, or were you like breaking down into functions or something in a code first description?
Yeah, we are breaking into chunks and maintaining the semantic context between each and everything. I will explain you in that matter. So, if there is no biryani in the word, it will not relate to the Indian cuisine. How will that model know if there is no semantic context between each and every chunk?